University of Cambridge teaching fellow Dr. Peter Wuthers is used to making things go with a bang.
So now you see him, now you don't.
And this year's Cambridge Science Festival lecture is no exception, as Pete sets out to explain how the everyday gases in our atmosphere are essential to unlock energy, even in our breakfast cereal.
Here we are at the Department of Chemistry in the University of Cambridge, and we're busy preparing for this year's Science Festival lectures. This is the lecture theatre that's going to accommodate over 3,000 people over 2 days for our lectures here, and the lecture that we're going to be giving this year is called It's a Gas. Now this looks at the properties of the different gases in the atmosphere. We're surrounded by the atmosphere all the time, but we don't really take notice of it in any way. The molecules are so small we can't see them, we almost forget that they're there. And yet these gases are crucial for our existence on this planet. One of the most important gases is oxygen, and this allows us to get our energy from the food that we eat. And it says on the packet that 100 grams of Rice Krispies provides us with 1,600 kilojoules of energy. And I'm going to add some oxygen. Now this is actually liquid oxygen. It's just that the gases in the air, the oxygen, cool down so it's in a liquid form. So this is a very concentrated form of oxygen. So this just ensures that there's plenty of oxygen around for the Rice Krispies to react with. Put on my goggles, and we're just going to apply a light to start this reaction, and you should notice the energy released. So that's 1,600 kilojoules of energy being released due to the reaction of our food with the oxygen around us. Energy can also come in the form of light. In my next experiment, I want to show how oxygen reacts with phosphorus, but there's a problem. Notice all the fumes that are coming out from this. I shall just lower the fume cupboard here. There's an awful lot of smoke being generated during this as the phosphorus is burning with the air. But in the lecture theatre, there isn't a fume cupboard, and we don't want to go gassing all the children with the smoke. So we've had to design a new set of apparatus where we can safely absorb the smoke with the solution. But all this smoke now is coming up through the tube, and it's actually being absorbed in this apparatus over here. So now we've seen how we can do this safely, we can really focus on getting the science across. So I'm just picking up a tiny little piece. So it's on the sand, and it's already caught fire. Oh, there we are. Look at that. So look at this. The light that we see here now is the reaction between this very reactive phosphorus burning with the oxygen that's in the air inside this flask, and it's making phosphorus oxide. This is a chemical reaction, but this chemical reaction is giving out light as well as heat. In this year's lecture, we will also see the explosive reaction of oxygen with hydrogen gas. Hydrogen gas can be made by the reaction of sodium with water. Now this is the sort of reaction that I want to demonstrate in the lecture theatre, but I mean, this was perhaps on a rather small scale. I think, well, how can we scale this up? So I wanted to show what happens if you use a really large piece of sodium instead of the tiny little piece there. So we had to come up with a specially designed piece of apparatus for this, and this was the sodium tank that you can actually see in the video from last year's lecture. It's actually bulletproof, this thing. So remember, sodium is a metal. I have a lump of sodium here. And we're going to add this to the water in the tank. I'm just going to wash this. This is in alcohol, right? And we're going to drop this into the water at the bottom. Are you ready? Go. And then get back. Oh.
Thank you.